Welcome to the Bentley Systems training course where we will show you how to model finite elements in STAAD.Pro Connect Edition. In this video, we're going to be focusing on specifying our plate properties, including specifying your plate orientation and assigning your material and thickness properties to the plate elements. We will start this video with a discussion on the plate local coordinate system. Plates in STAAD.Pro are defined by 3 or 4 corner nodes. This local coordinate system makes it possible to discuss the stresses on an individual plate element without having to resolve those stresses with respect to the global coordinate system. The locations of nodes A, B, C, and D are dependent solely upon the order for which they are selected when defining the plate element. Therefore, the orientation of the local axis system is also solely dependent on the order for which the plate corners are selected. The side of the plate from which the z-axis points in the positive direction is considered to be the top of the plate. In this video, we're going to explain how plate orientation can be modified as necessary on a plate-by-plate basis through the assignment of a plate reference point. Let's now turn our attention to the sample model that we'll be using in this video. The first thing I'm going to do is I'm going to turn on the plate local axis system so I can review how it's currently set. To do that, I'm going to go up to the View tab in the ribbon toolbar and select the Label Settings icon. Through the Diagrams dialog, we're going to see various different options that we can turn on and off on our screen depending upon what we're working on. For this exercise, I'm going to turn on the plate orientation, and then we'll go ahead and click OK. Now the first area I'm going to take notice of is the base of the structure. You can see here how I have a bunch of finite elements that represent the base of the structure where the supports are modeled. Let me go ahead and isolate that portion of the structure. To do that, I'm going to take any of my elevation views. I'm going to use my plates cursor and select all the plates within that plane. Once I do that, let's go ahead to the View tab in the ribbon, and let's go ahead and view selected objects only. And I'm going to reorient this so I can view a top view of the structure. Okay, so now what we're doing is we're taking a look at an isometric view of just the base of the structure so we can review the local axis system. As we can see, the local x-axis is pointing towards the center of the structure, and the local z-axis currently is pointing down. Now what you're going to notice is that the local z-axis for the horizontal plate elements at the base of the structure are pointing down. When the plate elements are analyzed in STAAD.Pro, the stresses at the top and bottom of the plate will be reported. The side of the plate elements pointing in the direction of the positive local z-axis will represent the top of the plate when the results are reported. For this reason, we're going to reorient the plate so that the local z-axis is pointing up, which will make it easier to interpret our results later. Now with this view still on, let's go ahead and find that tool. I have all of my plates currently selected, and in my ribbon toolbar, I'm now going to select the specification option. I'm going to find my plate tool, and I'm going to select plate reference point. Now what I'm going to want to do here is I'm going to enter a point that is basically above the level of this system. My current input units are set to feet, and I'm going to set the y coordinate as 20 feet, which is above this level. And I'm going to say point the local z-axis towards this reference point, and we're going to assign this to the selection. Once we're done, let's go ahead and click OK. And let's go ahead and take a closer look at what we did. So here I can see that my model has been redrawn and that now my local z-axis is pointing up for the base or horizontal plate elements of my structure. This is going to make it a lot easier later on. Now let's go ahead and take a look at the rest of the structure again. In the View tab in the ribbon, let's go ahead and display the whole structure once again. And now this time I want to take a look at the walls of the structure. So I'm going to select those elements, and again I'm just going to say View Selected Objects Only, and this time I want to take a look at a top view of the structure. Now we can see for some of these elements that the local z-axis for some are pointing towards the center of the state tank, while the others are pointing away from it. Now, to facilitate other operations, such as maybe modeling some pressure loads on the walls of this tank system, it might be nice to enter all or to adjust the model so that the local z-axis for all of the plate elements points towards the center. That way, if I were to model a pressure load, I could do it in the direction of the positive local z-axis. If I were to do a suction load, I might want to point it into the negative local z-axis direction. Now the plate reference point is given in terms of whatever the current input units are. And for this model, we're set to kips and feet. Now for my particular center point of the tank, I happen to know what the center point is in terms of inches. Now I could either convert them by hand myself, or I can tell the program I wish to enter this information in inches rather than feet. To change your current input units, we're going to go to the Geometry tab in the ribbon toolbar and select our input units icon. And instead of feet, we're going to select inches and then click Apply. Now at this point, with all of our tank elements still selected, we're going to go to our Specification tab in the ribbon toolbar, select the plate option, and then enter plate reference point. I'm now ready to go ahead and enter this information. I'm going to go ahead and point the local z-axis towards this point, and I'm going to apply it to the selection. Once we're done, we'll go ahead and click OK. And now you can see that all of my plate elements that I had selected have been redrawn, and all of the local z-axes are pointing towards the center. Let's go ahead and turn the rest of our structure back on, and we're going to save our model. At this point, we're done for this particular model, adjusting our plate reference points. So we'll go ahead and go back to our label settings icon, and we'll turn off our plate orientation. Moving on, we're now going to take a look at how to assign properties to plate elements, which includes the plate thickness and also the material properties. In your workflow page control area, you're now going to select your Properties tab, and then up in your ribbon, you're going to select your Specification tab. You're going to notice that when these are selected, the Properties Whole Structure dialog is going to appear in the Data area. Now in the Specification tab of the ribbon, we're now going to click on the Plate Thickness icon, which will be used to assign a thickness to a particular plate element, as well as the material properties at the same time. For my first property, I'm going to enter 0.5 inches, and I'm going to say that this is going to be a steel system. And I'm going to finish this off by clicking Add, which will officially add this property over to the Properties dialog. Now I'm going to repeat this process for as many properties as I'm going to need for my particular model. I'm going to need 0.75 inch steel, and I'm also going to need 18-inch thick concrete. Now at this point, I've added all the properties that I'm going to need for my particular model. And my next step in the workflow is to go ahead and start assigning them to the different plate elements in the model. So I went ahead and took a look at the elevation view. I can see that my plate's cursor is currently active, and I'm going to highlight my first property that I want to assign. This property is going to be assigned to the roof of my tank. So I'm going to highlight the property, select the elements I want to assign it to, and then I'm going to say Assign to Selected Plates. I'm going to repeat this process for the other plates in my model. So here I'm going to select my 3/4 inch plate property. I'm going to highlight the elements that this is applicable to, and I'm going to assign it. Finally, I'm going to finish off with my concrete base. Now, after you are done assigning your properties, you may want to view a 3D rendering of your structure. So in the View tab of the ribbon, you can select your 3D rendering icon to basically see what that's going to look like in space. In addition to that, it is necessary for every single member and element in your model to be assigned a property before performing an analysis so that the program can perform proper calculations for determining the stiffness or the weight of the structure. There is a tool available in STAAD.Pro to be able to detect whether or not you have any elements that have not currently been assigned a property. To find that tool, we're going to go to the Select tab in the ribbon toolbar and use the Missing Property icon. Here we're going to select Find a Missing Property, which will identify any type of element that is missing a section property. So that would be for members, it would be a section property. For plates, anything that's missing a thickness. And we can see that there's nothing in the model that is missing that information. In addition, we can go to Missing Property, and if we select any of these items, like Missing Elasticity, it's going to identify any elements in the model that are missing a material designation. And we can see that we don't have that scenario either.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.